Welcome to Podcast as Code, a show about the operations side of the software development lifecycle. I'm Mitchell Scott.
And I'm Gabe Cook.
Today, we're going to talk about a solution we built for a bank. But first, let's talk about some current events.
So there's a pretty big one, actually, kind of an elephant in the room. It's caused some drama online, and I'm sure some of you have already heard about it, but HashiCorp, who maintains a lot of open source DevOps services, has decided to make a license change to a lot of their projects. If you don't know their name, some of their products, they make Terraform, console, service called Nomad. They've made the whole HCL configuration language. Yeah, you're right. Vault. They make a lot of different things. So this license change, it's called the Business Source License, or the BSL. And this isn't a whole new license. A lot of projects use it. When I was doing some searching, it looks like Redis, MongoDB, MariaDB, and I'm sure a lot of other projects have a similar license.
Was this the one that Elastic switched to a little while back?
I think so. So this really feels like a little bit of a blow to the open source community, but I kind of get why they did it as a company. So Elasticsearch went through a similar thing recently. When was that?
I feel like it was last year. Yeah.
Yeah. So Elastic is a company that makes Elasticsearch, and it's a service where you can just throw all your data into it, and they give you a way to sift through that data and search. And they saw that AWS created a fork of their project and started hosting it themselves. So Elastic, actually, I forgot to mention, provides a cloud service that people can sign up for if they don't want to host it themselves. And that was great. You know, that's my favorite business model. We give you this open source thing, and then we also have a business if, you want to subscribe to that. Well, Elastic saw that AWS started hosting the same thing, and AWS is huge. So a lot of people already had AWS accounts, and they just started using what AWS calls OpenSearch, which is basically the same thing. And I think they started, losing some customers. So they changed their license. And in that case, AWS was big enough. They basically said, well, we're going to keep maintaining our fork with a clean room approach so that we won't violate the license. But it was a similar situation. Overall, felt like a bit of a blow to the open source community, even though I understand why they did it. I don't know if HashiCorp's going through the same thing, but that's what immediately came to mind for me.
Yeah.
I did some searching and noticed there were some cloud providers that offer a service similar to a service that Terraform offers, or HashiCorp offers with Terraform, called Terraform Enterprise. So not 100% sure, but it feels like it may be a similar thing. They started losing customers to other companies. So they decide, well, how can we stop this? And the way to stop it is the business source license. It doesn't actually hurt anyone just using Terraform as a service. We use it quite a lot at work to create, all of our projects in Google Cloud and clusters and different things in AWS. And it seems like we're going to be okay to keep using that. The people that really have to figure out how to handle this are people that actually fork the repository. So these cloud providers have their own version of Terraform that they tie into their website, and now they aren't allowed to do that. So the way around it is to, don't ever pull the future source from HashiCorp, because the latest version that they have was open source. But that's hard to do. It's really hard to do. You have to be able to, if you get sued or something, you have to be able to prove that you never looked at their source code.
Right.
You have to have a clean room approach. So it's awkward.
Yeah. So they posted the day this happened, which was August 10th. They posted a license FAQ on their website. And to their credit, they mentioned that they acknowledge that their code is no longer open source. It's source available, which is nice. Because it feels like sometimes when companies do this, like, oh, it's open source, but it's this license, which is not the case, because you are not free to distribute it. It is no longer open source in the way that, everyone has kind of come to understand open source. But like you said, I'll read a little excerpt from this FAQ.
Yeah.
It says, like, end users can continue to copy, modify, and redistribute the code for all non-commercial and commercial use, except we're providing a competitive offering to HashiCorp. And so that bit is the reason for the license change. They want to kill anyone who is competing with their enterprise or like cloud managed or hosted offerings. And on the one hand, like, I get it, it's hard to monetize open source software, but on the other, it's kind of hard not to feel like some of these open source projects are Trojan horses, because like Terraform and HashiCorp would not have gotten this popular if they weren't open source from the start. So I definitely kind of see both sides, but my general feeling is it's a bummer, because it was like a pretty nice beacon of open source software in the DevOps space that's now sadly no longer fully open source.
Yeah. It's always hard to monetize open source projects too. So I'm sure, that's fueled by that too, but I agree. It's overall a net negative, even if it maybe doesn't affect us from day to day.
Yeah. If I were starting to look at tools that did stuff similar to Terraform, I would look a little harder for a truly open source competitor.
Yeah.
We're probably invested enough that we're not going to change anytime soon, but we will be keeping an eye on the projects in this space to see if anything gets mature enough that we might want to switch over to it.
So one thing that I have seen since they released this license FAQ is there's a group of people that are trying to get a bunch of signatures for both companies and individuals who would agree to help maintain an open source fork of Terraform, which that would be pretty cool. It is not really doable for a single company, I think, to take that clean rune forked approach. But if, a bunch of companies band together and a bunch of people band together and help maintain it, then that may be doable. It's called the OpenTF Foundation. So they have a pretty big list of companies and individuals so far. We'll link to their website in the show notes. So that might be a promising change from this. Although I still have some concerns with it. Terraform still is created by HashiCorp. So, they really have the most history with the project. My only worry with this OpenTF Foundation is if HashiCorp decided, 6 months from now, and I don't even mean maliciously, I just mean if they decide, okay, we want to add some fancy new feature to Terraform and it's going to break any existing plugins, then it fragments the user base.
Yeah.
Then some plugins would work with the official Terraform, some would work with this OpenTF Foundation, and that wouldn't be good. Who knows? Maybe they will never do that, but breaking changes happen, and I don't really know how that would work with this foundation maintaining a third party of Terraform.
It'd be tricky for the community, even if it is the whole community and not just a person or an organization. It'd be tricky to maintain compatibility for a long time. That's a lot of work. There's a ton of plugins out there. So that's...
And maybe if this foundation gets big enough, then maybe the plugins will stick to their spec, but that's still a fragmented user base. And maybe they'll maintain their own fork of the plugins, but who knows? It's tricky.
Yeah. I'm kind of a little worried about HashiCorp in general lately. Just like, are you guys okay over there, HashiCorp? Because they've announced some changes recently, like Mitchell stepping down to focus on more day-to-day individual contributor stuff. And now this, it's kind of, I wonder what's going on over there. I hope they're doing all right.
Yeah, I hope so too. While this change isn't my favorite, they've done so much for DevOps in the past. So hopefully they're doing okay. Hopefully that news post they made with Mitchell stepping down is more, he realized he likes being a developer more than anything, and he would prefer to write code for HashiCorp than to be, CEO. So hopefully they're doing all right. That's a good point.
All right. So on August 15th, Kubernetes 1.28 was released. And my overall kind of feeling for the more recent Kubernetes releases have been, things just kind of seem to be getting more stable and more mature. There's kind of less cool stuff happening, or less new breaking stuff happening, and more like the groundwork that had been laid in previous versions is now getting to general availability, and everything's just stabilizing a little bit.
Yeah, it's been nice though. When we're upgrading all of our clusters we maintain, it's usually just upgrade to 1.25, then 26, then 27, and it goes pretty smoothly.
Yeah.
But I agree. A lot of the recent additions have been, some beta feature is now generally available. So one of the ones that seems pretty cool to me is that they are increasing the version skew. So previously when you have a control plane running and then nodes running, there's a very tight requirement of they have to be very close version wise. And it still looks like there were some limitations to it, but that skew growing a little bit would help with, upgrades or something like that. It seems like to me.
Yes.
So that's pretty cool.
Yeah. So previously, I think the skew was 2. The max version difference was 2. So all that basically let you do was upgrade. If you were upgrading a cluster from, say, 1.27 to 1.28, you could take your control plane to 1.28, but before you took your control plane to 1.29, you would need to bring your workers up to 1.28 because you could only have a version difference of 2 between the two of them. That's now increased to 3. So in theory, you could run your workers on 1.27 and have your control plane on 29, which I guess is nice. I don't like running the workers on a different version than the controller. Kind of feels weird to me. I do get that there's some shops that, upgrading the control plane is typically a non-outage causing event. Like, especially if you're multi-controller, you just rolling update the controllers and then everything's fine. Workers are a little trickier. You do have to take those effectively down. You have to drain all the workloads off of them. And for stuff like stateful sets, like a database or something, that's not always a zero outage event, depending on how you have things set up. So I guess there's places where this makes a lot of sense, and I'm sure those folks will be really happy to be able to take less of an outage.
Well, I think the goal would still be to keep them on the same version, but what maybe could be possible from this and would be really nice is if you don't have to do as much stair stepping, like upgrade one version at a time. It'd be nice if you could jump versions or something like that. I think you
still have to stair step, but I would have to confirm that. The case they specifically, like the Kubernetes project specifically mentioned, was folks who want to keep current on the API for security purposes, but can't take their worker nodes down as often. So that use case, people would be running on the newer control plane for like half a year.
Yeah. Well, but do you not think you could upgrade your control plane twice? In this case, even if you have to stair step and then jump your workloads?
I don't know. You could definitely run like 2 newer control plane versions, but I don't know what the upgrade path is for those workers. If you would have to stair step them, you could do that in a single window, but it would be nice if you could just directly like install the newer packages or whatever on those workers.
That's what I'm hopeful for. I can't tell yet. I'll have to play with it.
Yeah, we definitely haven't taken advantage of this yet. And like we said, this just released on the 15th. I don't believe it's available in any of the public cloud platforms yet. They usually lag behind a little bit of the like main Kubernetes release channel.
Yeah. Yeah, they stay behind a bit. So some other things that they've changed, they changed some non-graceful node shutdown recovery to general availability. I actually didn't even realize that this was in beta previously because it was enabled by default since 1.20. But before 1.20, if you had a node unexpectedly shut down in an unhealthy way, like it loses power, I guess some stateful sets and things could get stuck. Had you ever seen that?
I haven't. I don't think. I've had weird problems with some of my home clusters, but I don't think it was this specific case.
Mm-hmm.
I think I started my cluster out on 1.20, so I think that would have probably been enabled for me.
Nice.
But yeah, when I read about this, I was like, oh, is that a problem? Because I didn't realize that was a problem. And I think it's because it's kind of been fixed in beta for a while. But again, nice to see something graduate to general availability.
Yeah, and I started with Kubernetes, I think in 1.16 or 1.17, but that was in cloud. So you really never had
like an outage for a
dirty
node
shutdowns. Yeah. I started my personal cluster on 1.22, I believe. So quite a bit more recently. I think the coolest one to me, the flashiest looking one, isn't even generally available yet, but you can set up an init container now to keep running. So previously, within a pod, you can have containers that start up before your main process. And you also have what's called additional containers or sidecars that run alongside it. And that was it. So now it's cool that you can have a container start before your main workload and then just stay running. Seems useful for like a VPN connection or something that you want to be sure starts up before your main workload does.
Yeah.
I think that's in alpha right now, but I'm definitely going to experiment with that one first when I hop to 1.28.
Yeah, I could definitely see that being usable for some sorts of sidecars where being started ahead of the main container would be beneficial, and then stay running would be, a requirement there.
Mm-hmm. That was mainly it. There's a bunch more bullet points. We'll link to them in the show notes, but those are the ones that stood out to me, and I think you too.
Yep. All right, let's move on to our main topic. That time we did a thing for a bank. So I can give a little bit of the background here. The company that Gabe and I work for was engaged to build a mobile application for a community bank local to our area. And we weren't really involved in that part of the conversation. We don't really deal with the mobile app development stuff. But they asked something towards the end of the sales cycle for that application. And it was, hey, do you guys know anything about Kubernetes? And so Gabe and I got roped in and we're like, yeah, we know a lot about Kubernetes. We
were really excited.
Yeah, we were super.
I'll add.
Yeah, we were super excited to sell DevOps work because a lot of the work we do is kind of internal, like keeping all the applications running and stuff like that. We don't often get the chance to go like architect new stuff for clients directly. So this was really cool. So we're like, yeah, well, of course we do Kubernetes. We love Kubernetes. It's the best. And so we got brought into this project where a community bank wanted to, it's actually a really cool idea they had, which was, they've got a lot of different applications. They've got like their mobile app, their online banking app, random internal applications.
Telephone banking.
Yeah, telephone banking even, where like you call a number and you get their IVR, their integrated voice response. So, press certain numbers to do things like you can do balance transfers and all that stuff. And all of those things talk to different systems. And some of those are internal systems. A lot of those are external systems like their core banking data provider, check scanning endpoints. I mean, tons of random stuff. There's probably, 20 systems that all these things talk to. And for each time they built an application, they would have to integrate that application with all the pieces it needed to talk to on the other side. And they wanted to work in kind of a more modern and more abstracted way. So they had this idea to build basically a shim layer in the middle of all of that traffic so that the applications could talk to this layer, like an API layer. And that layer would handle all the backend communication to the various places and then just present the data to the apps. So they could kind of write once in all these applications. So, a balance transfer is always just a balance transfer. The application doesn't care what the backend system is, which would open this community bank up to more easily switching their core banking provider if they needed to, or, swapping out different external services or vendors and not have to change their applications. They just change the API layer. And that was a really cool idea. And they also wanted to build it using microservices. They wanted to use Kubernetes, but they didn't have the experience in-house running production Kubernetes, but B, like the time for dedicated resources to spend on the infrastructure side when they're also working on various different applications they're building and all the rest of the things that you would expect a community bank's IT team to work on, There's printers to smack, there's like workstations to deploy, firewall policies to change, all that stuff. And it's a pretty small team because it's, like you said, it's a community bank. It's not one of the 4 largest banks in the country or anything like that. So they've got limited resources on the payroll that can build stuff like this. And so we got brought on to help them build it. Being a bank, they have some pretty strict requirements with things like uptime. And I'll say too, this is all on-prem. They're very cloud hesitant. They want,
understandably,
right. And that brings a lot, like running stuff in the cloud for a financial institution brings a lot of compliance things that they are not at the point that they want to deal with, which totally understandable. So it's all on-prem. So we needed to architect an on-prem solution that could tolerate power issues at their data center location. And when I say data center, like it's in their building, it's not like a colo or anything like that. So we have to account for power, like internet disruption at the site. So like that data center can go dark, like that internet connection can fail. Weather was a big one. The area they're in is pretty prone to tornadic activity. So it's not something you think about if you haven't been in one of these like geographical areas where tornadoes are a thing you have to deal with. But because typically, you're like, oh, well, I have another location like a mile away. That's on a different power circuit. It's got a different internet provider. That's fine. It's completely separate. And then if you look at the ground track of certain tornadoes, you're like, oh, those can go for a mile or two. And if it's in a certain direction, it's more likely. So
it could conveniently hit both.
Right. That would not be good. So it needs to be pretty far away. Needs to have good connectivity to the primary location.
And even like hardware failure of the servers.
Yeah. So you have like inter data center failures, like nodes failing and stuff like that. You also have like the entire data center goes dark either due to power, a weather event, or the internet's out, right? So we need to solve for all of those things.
Or even things that we could cause, like Kubernetes upgrades or firewall policies or something.
Yeah, and Kubernetes upgrades can be a little scary because they're a one-way street. Like you can go up, there is no documented procedure to downgrade. So that was another consideration in play here is what happens, if it's a single cluster just stretched across locations, what happens if an upgrade goes sideways? How long does it take us to rebuild this environment for them from the pieces? Those are kind of the challenges we had with architecting the solution. And again, it was really fun to solve this and work with them on the requirements and the various bits of the solution. So the solution we arrived at, Gabe, do you want to talk about it?
Yeah. So what we have running is 2 main data centers, and there's completely separate Kubernetes clusters in each one. They're a good distance away from each other so that both couldn't be affected by, a single power outage or anything like that. And
like they're in different cities.
Yes. Different cities within a state. And then the actual deployments are managed, with tools we've talked about in the past. So the clusters don't actually talk to each other at all. And we have a repository with all of the versions and deployment configuration. And we run fluxcd in each cluster, and it will, whenever a change happens, it'll deploy it to both clusters simultaneously. But again, they don't talk to each other during that deployment at all, which is different, at least in, from what I've done in the past. So that was pretty interesting. To manage incoming user requests, we worked with them to deploy kind of a cloud load balancer. So that is one thing that's in the cloud, although it's set up in a way where that cloud provider can't see the traffic. Right. It's encrypted as it goes through the cloud provider. But I think that's the only thing that's running in cloud.
So there are ways to do global load balancing on-prem or in a more on-prem way. And we evaluated some of those here, but they're really expensive. I mean, there's stuff like Big Leaf is one that I've used before, in the past. And you basically have 2 different networking nodes at each location. And then Big Leaf has some networking bits. I guess it's kind of cloudish, but it's all the networking layer. So it's not quite the same, and it does have some on-prem components, but it's an expensive solution. And in the end, they were able to get to a place that satisfied their security requirements with just a basic cloud load balancer.
Also, are those, I've never used any of those. My background is more cloud computing. Are any of those as plug and play as the ability to deploy a cloud load balancer and then use it? Or do you have to work with your internet service provider to get some, any sort of custom routing? I have no idea, honestly.
I believe they're plug and play from the ISP perspective. I believe they're effectively tunnels out from your internet to like that vendor. And then some of the routing is happening on their network and then VPN to you effectively.
Okay.
They are really cool. You can use them for like, in the past, we've used them for WAN load balancing. So 2 internet connections, maybe one's not that great, but you effectively build tunnels over those out to, like in our case, it was Big Leaf. And then they handle the link aggregation for you, which is pretty cool. I think you'll see this called like software defined wide area networking, or SD-WAN. And it's kind of buzzwordy. It is a cool solution in some cases, and there are good use cases for it. But yeah, it's not as plug and play. Like that one, you had to have some of their hardware like shipped to you. So definitely not as plug and play as like, clicking in a cloud interface and then getting the load balancer you want in a couple minutes.
Yeah. The cloud load balancer is nice because I think it's similar to some of those solutions, but you then can get a single endpoint and put that behind your DNS. And then if both data centers, optimally are both running, you can route users to either one. And that, depending on, your circumstances, that could be what's called sticky. So you could make users just point to a single data center, or it could not be. And, if your infrastructure can handle this, they could just go to either data center, one request to the next, which was very useful.
Yeah, and kind of the easiest way to do something like this, like it's kind of the cheap and dirty way, would be something like DNS. Like you could put both data centers' IP addresses in DNS, and DNS would just round robin load balance between those two. That has some really bad limitations, though, including like
caching is what I think of.
Yeah, caching for DNS, like me as this bank, I can't go and validate someone's DNS cache if a data center is going down or is down. Mm-hmm. Additionally, DNS doesn't really have the concept of health checks. Route 53 may have some, but they're pretty rudimentary.
But still, it feels like you're taking advantage of a spec that's not supposed to work this way, even if it does work.
In my opinion, DNS-based load balancing is a little bit of a hack. Certainly, there are use cases for it, but in this situation, it seemed like we needed a lot more control over, like, if a data center's down, that means if someone gets routed to it, they can't get their banking information, and that is a very bad day for that person. Like that's an unacceptable situation for the bank to be in. So we went with it's a layer 4 load balancer.
Yeah, it's layer 4. And that's why, we can send traffic through it without the cloud provider actually seeing what's happening, because it's just working at the TCP level.
Right. And so what that means is like the cloud load balancer is not decrypting TLS. That's still happening on-prem at the bank. That is not happening anywhere. So like you said, the cloud provider can't get to the data in those packets, which was really important for the bank to feel comfy with using the cloud. It's as secure.
I'm sure that simplifies some sort of auditing too.
Yeah, I mean, it's as secure as that data already is going across the public internet, which it of course is. So it means you don't really have to extend like your ring of trust fully to the cloud provider, because you're still 100% encrypted through that cloud provider.
So once we go through the load balancer, we have multiple workloads running in each cluster. They obviously have to share data in some way, and we used a multi-primary clustered database for this. So there's a bunch of different microservices, and they do have their own database instance running in each data center, but the databases will asynchronously talk to each other to stay in sync when possible. So we used Galera. It's called MariaDB Galera cluster for this. And it has some small limitations, like you need primary keys on every table, and some locking statements won't work. So there's some things to keep in mind. But so far, it's done a great job at keeping each data center replicating without getting in some weird split brain mode.
That's actually running outside of Kubernetes.
Oh, true. Yeah.
We could certainly run it in Kubernetes, but there was some discussion about how many resources, particularly memory, it took up, and it was decided to keep that out of the cluster so we could free up cluster resources for things that absolutely had to be in Kubernetes. Additionally, with a lot of these highly available solutions, like 2 locations, like we have a primary and secondary data center, 2 locations is not enough for high availability because of split brain. So if a data center goes offline, that's fine. 1 data center's up, the database is happy. But what happens if there's just a break in connectivity between the data centers? Each data center thinks it's the only one.
Be out of sync.
And drift happens. So you usually need an odd number of nodes for what's called quorum, so that 50% plus 1 can vote on who's in charge. So in our case, there's actually a 3rd location in play here, but it's not running Kubernetes. It's running just what's called like a Galera witness. And so all that guy is doing is it's getting all the storage traffic. It doesn't actually store anything, so it can be pretty light on disk usage, but it's just seeing the storage traffic and voting in the member elections.
To decide who the real...
Right, to decide. So if there is a communication split between the primary and secondary cluster, this guy has connectivity to both outside of that conduit and can see, okay, one of you is in charge, here's who it is, and everything's fine. And like you said, we haven't really had issues with this. It's a pretty sophisticated setup. It's not one I've really messed with before. Multi-primary databases, like distributed databases. I don't like that.
It sounds wrong. Not being able to lock tables seemed like a pretty big limitation to me at first, but it hasn't caused any issues for us. So you can still lock individual rows, and it seems to just work. Now, you mentioned that's not being hosted in the cluster. Even without the database itself in the cluster, we still built some automation around some of the provisioning. Do you want to talk to that?
Yeah, so I think we've mentioned it on a previous episode. It's a project called Crossplane, and it is a
Terraform-esque.
Yeah, I wouldn't say a competitor, but it is a little bit Terraformy, where you're declaratively creating infrastructure or, whatever. And there's a SQL provider for Crossplane. So Crossplane's running in both clusters. Its manifests for its objects are stored in Git. Those are synced via Flux CD. And so what that does, so whenever we actually wrote it into the Helm charts we built for these microservices. There's some Helm values you set that's like, yes, I'd like a database, please. And what that does is it generates the YAML that Crossplane ingests saying, I need a database, I need a user, and I need a grant. So I need to make sure that user has full permissions to that database. When the SQL Crossplane provider sees that, it goes and builds those resources in the database. It's not even in Kubernetes. So it is really slick because we're able to take advantage of some Kubernetes style GitOps automation, even though the database we're talking to is like, it could be running in the 90s for all we know, right? Like it's, as far as we care, it's just SQL. Right, exactly. Yeah. So that's pretty slick. It is really nice for our developers. Our developers have been deploying microservices without the DevOps team. So they've gotten so familiar with how all of this works that they're able to deploy new microservices that they have written without us even knowing about it, to the point that like one day we logged into the cluster and like, oh, what are these extra 10 services running? Like,
there's so many microservices.
It's awesome. So Crossplane, and I will say the learning curve for me getting that working, it was pretty steep. I had to build some composite like resource definition objects and stuff. So it was really quite difficult. And in the end, at least for me, because I'm new to Crossplane, in the end, it basically ended up being a Kubernetes operator almost, where we built our own CRDs, our own custom resource definitions, and then Crossplane goes and builds the pieces that make those up. So really slick. And it's not the only operatory thing we've built here.
No, so good segue. To communicate all the microservices talk over a service mesh-esque project called Nats. And we wanted to try to automate some of the Nats provisioning too. And they did have an official kind of operator for auth, but it was deprecated. It didn't work exactly how we wanted. So we built one. This one is actually natively written in Go using the kube builder framework, which I think I mentioned in our Kubernetes talk episode. But basically, it will look for different user and account CRDs, again, in Kubernetes, and basically reconcile the state of Nats to match the state of the cluster. So it's pretty much the same deal. We can make a user with the Helm chart, say, hey, I want a Nats user for this microservice. I want it to only be able to talk to specific topics. And then the operator will do sort of a reconciliation, and it'll create that user in Nats. If it sees the topics change in Kubernetes, it'll update the topics that it has access to. If it sees the user get deleted from Kubernetes, it'll go delete and revoke access immediately. So it was pretty fun to build that operator. I had a lot of fun with it. It's funny too that we have one operator built in KubeBuilder and then one built in Crossplane, which I think is in KubeBuilder. So in the end, we've kind of just built two operators, but different styles.
Yeah. Important to note too is that Nats is not bridged between the clusters. There are separate Nats instances in each cluster. So the operators also, the Nats like operators that you built, Gabe, those are also running kind of solo at each cluster, handling the Nats state. And it's all working really well. Like, it actually, we haven't had issues with keeping things in sync. It's been great, actually.
They are, and I actually configured it in a way to where we don't request any sort of passwords. So there's not predictable passwords for Nats. We create the user CRD in Kubernetes, and the operator will automatically make the user generate a really long password and then put that back into a secret, which the microservice can pick up and then use that secret value as the password. So each cluster actually has a separate password for each microservice to Nats. So there's no possibility to accidentally cross-communicate, which is really nice.
Yeah, you mentioned secrets. We had some struggles with secrets with Galera too, because while Nats isn't bridged between them, Galera effectively is, right? It's a distributed database. Both clusters are talking to the same database. The same users have to exist. The same passwords have to be for those users. So it took us a little bit to get that worked out. We came up with a pretty elegant solution there that I'm not going to dive into, but I will say it was a little trickier than if we didn't have to solve for, two clusters talking to effectively one database. It was a little complex, but it's working, and it's working really well. And I think we landed in an elegant place with it.
Agreed. So then we have two clusters running. We have deployments going. Honestly, early on in development, there were a lot of cases where, especially because we're used to working in cloud environments, one of the microservices would have an issue and crash, and it was hard to get that visibility into the cluster. So monitoring has definitely been an important part of this.
Yeah, and I'll say too, monitoring is more important when you're highly available like this, because you could have a service fail in one of the clusters and the load balancer is just like, oh, you're dead. That's fine. I'm going to route to the healthy one. You don't know, you don't get an outage notification when that happens, because the service is up by design, highly available. So you have to have monitoring pretty dialed in so that you're aware when you're kind of down to being in simplex where you only have one healthy thing left, so you can go fix the other stuff.
And then actually, that does bring up, I may have forgotten to mention earlier with the load balancer that it does do active checks, the load balancer in cloud. So it will do that. If a single data center, one of the necessary services goes down, it'll just start sending traffic to the other one. You're at more of a critical place there because all traffic's relying on a single cluster.
Right.
So we deployed the Prometheus stack, which I think we talked about also in our monitoring episode.
Yeah.
And we have a bunch of alert manager rules set up to get notifications. That part's still a work in progress, in my eyes at least. But I know it's solved quite a few app outages that would have been a pain point before we had it.
And something else is centralized logging.
Yeah.
Gabe, you and I didn't build the solution for this. The client already had a logging platform they liked, so we just helped them facilitate shipping logs from the microservices to their log platform. But they do have a centralized logging platform because, again, with an active-active setup, it's critical to know which ingress controller did whoever having an issue hit. If we're testing the mobile app and there's you get a 500 or whatever, what cluster was that user talking to when they got that error? So we can go dive deeper into logs or whatever we're doing to troubleshoot. So centralized logging is critical for troubleshooting with highly available applications like this, because otherwise you'd be looking all over the place for things.
That's true. That would be really frustrating to have to check both.
Yeah, for
every time.
Yeah, every single time there was a problem.
Mm-hmm. I think I alluded to this earlier, but to try to keep these clusters in sync with Flux, we have kind of split up the build and the deploy stages to separate repositories. Each microservice lives in its own repo. We build whenever it gets a push. That's pretty standard. But the only time we deploy is when the version changes in sort of a mono repo, which can version every microservice against the other microservices for a given, like dev environment, which fixes a lot of issues. In the past, I've read, so many articles about how hard it is to version microservices. And I think that solved a lot of the issue.
Right, because you'll change a thing on one microservice that has a dependency somewhere else. They need to talk to each other.
Mm-hmm. And how do you time that deployment?
Right. So yeah, like you said, we kind of have a pseudo mono repo, and that's the only time deploys happen is from that repository. And that part has also worked really well.
Yeah.
It was kind of a pain to think through early on, like, oh my God, how are we going to do this? Because we need builds to happen per service so the devs can test individual builds out, like when the services are working on, but we only want to deploy the whole thing at once. And we've arrived at a pretty elegant solution for that, given the constraints. It does kind of only update the services that have changed, which is nice. So you're not rolling out the entire 40 services or whatever every time you need to do a deploy. It is smart enough to only roll out changes to things that have had changes. But all those things are so the versioning is kept kind of in lockstep through the deployment phase.
Yeah, and even those blue-green. So ideally, any deployment should be pretty seamless.
Yep.
But yeah, overall, I mean, it's been a lot of fun to work on. It feels to me like some of it is still a work in progress, but it's in recent months, it's impressed me at how solid everything has been.
Yep. We have not had an unplanned test of failover yet, so TBD there. But it's architected to work well, and I don't expect any issues. But I'm sure we'll have a maintenance window and try to do some failover testing.
Mm-hmm.
But yeah, it's working really well, and it's been one of the most fun things I've worked on because of the fact that you and I got to architect it and build it from pretty much start to finish. And it's a complex thing to solve, which is super fun.
And it was really fun to have a client that already was familiar with even the term Kubernetes and was completely open to it.
Yeah.
And there was no need to sell the benefit of it or containers. They were already on board, which was pretty great.
Yep.
But I think we've covered everything I wanted to talk about.
Yeah, same. Awesome. Thanks for listening. Our website is podcastascode.show. If you would like to suggest topics for us to cover or have feedback on topics we have covered, send us an email. Our address is contact@podcastascode.show, or you can hit us up in our Discord. Our next episode will be about build automation, and due to me traveling, it will be delayed a week.
Yay. See you next time.